It's the Life Upfront Engineering Podcast. I'm your host, Jeff Waters, covering ideas, people, and products on the cutting edge of product development. As always, join the conversation at lifeupfront.com. On this episode, we have an art lover, snarkmeister, connoisseur of fiction, engineer, CFD guy, and company president of Pointwise, John Chawner. John, I think that probably covers it all, right?
More or less, but it's great to be here, Jeff. Thanks for inviting me.
Hey, my pleasure. So Pointwise is a company focused completely on meshing for CFD, which, in the circles that I run in, we're 0.0005% of the human population that knows what CFD stands for, much less meshing for CFD.
Yeah, that's definitely true. It's a niche within a niche. We've been doing it as a company for 19 years now, believe it or not. Our product is the same name as the company, Pointwise. That's our next generation product. But the classic product that we started the company with, called GridGen, actually predates the company, goes all the way back to 84. So I've been doing this for a long time. Ah,
okay. So you just taught me something new. I thought GridGen was the product, so I may be behind the times a bit.
Yeah, that's about, I don't remember how many years ago, 5 years ago now, 5 years ago, we went through a multi-year stretch where we wanted to take GridGen, which I describe as 10 pounds in a 5-pound box, and re-architect it for another 20 years of life. And that generated the new product, the next generation product that we call Pointwise. You can imagine that when you have a product that's been under development since 84, 87, that kind of time frame, that was started by three gentlemen in their early 20s, that number one, things change along the way, and number two, you might not make some really good architectural decisions when you're in your early 20s, believe it or not.
Well, now this is interesting. When you make a change, I'm supposing that the change was from something that maybe was a little clunky in feel compared to, what at the time you considered to be a modern software tool. That seems to be what most engineering companies do, most companies, software companies in general. But, for something that's this dedicated to a customer and, becomes a pretty big part of their life, I'm assuming, that could be a shocking change. Do you still have people who refuse to make the switch? Are there GridGen lovers out there who won't let it go?
Oh, absolutely. And we knew that going in, and that we don't fault anyone for that. We expected that because there are a number of reasons. Some people don't like change. I'm one of them. So we realize that some people just want to stick with what they know. I mean, that's one of our mantras is, use what you know and use what you're comfortable with. And we know that there are also business reasons or implementation details at a certain user organization that doesn't allow them to change. Large part of our history and our customer base is military, aerospace, defense. And those folks, sometimes when you get started on a project or a program using a particular tool set, you can't change. So if you start using GridGen, you use GridGen, through the life of the program. So we knew there were things like that coming up. We have people who had, bought perpetual paid up licenses. We're not forcing anyone to change. Our goal is to make people desire to change. And we believe that Pointwise is a vastly superior product in terms of the workflow and things like that. Kind of going back to the beginnings, GridGen originally was developed. It was written in Fortran. It ran on a VAX 11780. We did the displays on VT100s and then VT240s, if you remember those, with that orange text on the screen. And then back in the day, we were the first program that got ported to the first SGI workstation that our employer acquired back at that time. So we went 3D and interactive then, but it was still Fortran. It was pre-Motif, pre-MFC. So we invented our own GUI. And here's a little bit of trivia. The GUI that we wrote was actually rendered and managed in OpenGL. So you get all this infrastructure in place and you don't want to change it. We spent all our time running meshing algorithms that sat behind it. That becomes, like I said, 10 pounds in a 5-pound box after a while. And you want to do something like, let's change the user experience for the better by making it not only more modern, but, streamlining the workflow, putting in more automation, making it so that it's very, light from the top, very customizable and things like that. So we were highly motivated to make the change. Many of our customers were, telling us to make the change. The ones who, weren't the ones sticking with GridGen, but it was well worth it at the end of the day. As most things like that takes longer than you ever thought it would, but it's worth it in the long run.
Well, let's take a quick step back. One of the big questions that I think a lot of people in my audience will have is, hey, I've heard of Fluent, I've heard of Star CCM Plus, Star CD, CFX. They all have preprocessors. So why is there a company out there that does just preprocessing for CFD?
Well, there are a number of reasons for that. One of which is actually contrary to your original premise. Not every CFD solver comes with a preprocessor. Yes, many of them do, but some don't. Open source tools, academic tools, US government CFD codes, proprietary CFD codes that are developed by certain customer organizations who get a great competitive advantage for whatever reason by their special skills in developing a special tool for doing CFD. They need a mesher. They don't have access to the tools that Fluent provides or Star CCM. So that's one of the opportunities. The other part of the opportunity is what we find is most CFD users don't use just one code. They may have one that's primary that they use for, a lot of their everyday analysis, but they may use a couple other ones for special cases, special configurations. Like on an aircraft, they may use a different CFD code on the ECS or environmental control system or things like that. Then it becomes an issue of, well, why do I need to learn two preprocessors or three in order to do that? And that goes back to the other premise to answer your question about why is there a world for independent preprocessing is that people don't want to learn multiple meshers because meshing is it's a completely unglamorous task. It's very difficult. It takes a lot of time. People still use the benchmark that preprocessing, quote unquote, takes 75% of any analysis. And at the end of the day, you're still just preprocessing, right? Because everyone wants to just do the CFD and get the engineering data out of it. So people are trying to do whatever they can in order to speed up or minimize the amount of time they spend doing meshing. Remember, if meshing takes 75% of every analysis, the big improvements in analysis throughput are going to come from improvements in the meshing side of things. So that's really the business opportunity. Can we do meshing faster? Can we provide the tools that allow people to knock meshes out faster in a different way through customization, macros, templates, or just the basic core suite of meshing technology? The other thing that, so going back again to your original premise, who needs a mesher like ours? Number one, people who don't have one to start with. Number two is people who are experienced enough in CFD to know that they need a better mesher. And coming from the aerospace and defense side of things, we're used to working with clientele who are very, very interested in accuracy of the computed solution. So we try to build our software and our meshing technologies and deliver meshes that achieve those goals. But then those attributes of the mesh are then applicable to anyone who's doing CFD, who realizes that, hey, if I could do things differently, better, come up with a better mesh, then my answers will converge faster. I'll get more accurate answers and things like that.
So I get it, and the first reason you gave me there kind of resonated. I've spent most of my career taking usually new CAE software into companies. And, one of the things that a lot of people in the company have a vested interest in is not allowing proliferation of tools. So they want to cut back on the number of tools. So I think I was initially kind of thinking in the back of my head, well, okay, they already bought something that has a mesher or could have had a mesher. Why are they going to invest in this? But I get it now. If you could say that, well, for capability reasons, not every CFD tool can meet every need that you have. So especially in really big companies, they are going to have multiple tools. And if you could be the universal remote like I have for my TV. I've forgotten how to use the individual remotes for each of the components, but I got the universal down.
Right. Yeah. And it's a matter of, we recognize as part of our business model that some people are going to say, I bought Fluent, it comes with a mesher. I have Start CCM Plus, it comes with a mesher. My boss isn't going to pop for another piece of software to duplicate something I already have. We kind of rely on an educated user, and I don't mean that in a pejorative sense of the word. I mean that as they develop experience, a lot of users will come to the realization why an independent tool like that fits better into their overall workflow. It's kind of like a rising tide lifts all boats argument. We're very big advocates of CFD, even if that's open source, because it brings more people into the market, gets them starting to use the tool, understanding the benefits of CFD, and then they gradually begin to appreciate tools like ours. And I think the arguments I'm making are the same for why there are independent pre- and post-processors for CFD, like FieldView from Intelligent Light or TechPlot or Nsight from CEI. It's the same kind of business value proposition there.
And, now that I think about it, you are right. Not every tool, not every solver has a preprocessor, particularly open source, which is getting really, really hot these days. I've been kind of amazed at some of the companies I've seen either exploring or already adopting open source CFD solvers and FEA solvers.
Well, open source removes initially one of the big barriers to people getting into engineering software of any sort, which is price. Right, because it's free. There's no upfront cost. It's free in the same sense that a free puppy is free, but it's free nonetheless, so that people can get it and start using it. It allows them to solve interesting problems. It's great for an academic setting. Open source allows people to get a piece of code, extend it according to their areas of research, put that back into the community. Stanford SU Squared is a perfect example of an open source CFD tool that comes from an academic environment. Of course, certainly one of the bigger ones that's out there right now is OpenFOAM. And that's not to say that there aren't measures that are available to that group. I mean, there are a number of open source measures that they can use to supplement their toolkits. And from I mentioned the business proposition of trying to sell to someone who already has another mesher that they got with a commercial tool. The way one goes about selling a commercial mesher to someone who's got a free CFD tool is also an interesting one as well.
So, let's back up and peel this onion a little bit deeper. We said a niche within a niche, within a niche, within a niche. This is meshing primarily for CFD.
That's right.
Yeah. Now, FEAs, requires just as much meshing as CFD. So how in the world did you end up just focusing on CFD? And, do you have plans to also adapt some of this technology for more structural use?
Okay, so how did we get focused on CFD? That's kind of an easy one because that's where my background comes from. And my co-founder, John Steinbrenner, he and I both met back in 1984 when we both started working for General Dynamics here in Fort Worth, which is now Lockheed Martin. And I think that was the same year they started a CFD group from scratch. So by necessity, John was tasked with developing the mesh generation tool, specifically targeting that customer, as someone who's doing external aero and internal aero for fighter aircraft. So it comes from the CFD side of things. I started out there, my specialty coming out of undergrad was gas dynamics, and I started out there in the propulsion analysis group doing nozzle flow fields, and I was tasked with, okay, we're going to start using CFD, figure out how we're going to apply that to the nozzle part of the business here. And after 3 years, I'd started doing graduate school for my master's degree, and I took a course in grid generation from Rich Hindman, who was teaching at UTA at the time, UT Arlington, who is now, I think, retired from Iowa State. And his course on mesh generation was so fascinating, I knew that I wanted to get involved in that. And I ended up transferring into the CFD group with John Steinbrenner and working on one of the early versions of GridGen. So that's kind of historically where we come from. That's kind of where our strength is and things like that. So how does CFD meshing differ from FEA, and might we go that way in the future? Keeping in mind, I've never generated an FEA mesh in my life, and I've never done FEA. That's not my thing. So everything I'm going to base my argument on is kind of secondhand. But I think that CFD meshes tend to be bigger. Matter of fact, we just made a mesh in-house last week for a project that was 1 billion. That's a billion with a B cells. So they get to be kind of big. I remember being at a show or something next to the FEMAP guys, and they were giving us a hard time because they were pointing. We had some meshes up on the screen, and they said something like, "Look at that! That's why we don't do CFD meshing, because it was another big mesh." I think the other thing that's true about CFD meshes that it makes them different from FEA is the length scales involved. We're doing we have length scales that vary 6, 7, 8 orders of magnitude in the same mesh, from the finest cell that's near the boundary or in the boundary layer, resolving the near wall effects, to large cells out by the far field boundary. So we have that level of detail, geometrically speaking, which really, we've made meshes where we're pushing what can be done with double precision. We actually run out of significant digits. And we have to do some special things to handle that. Heck, even the graphics in the Pointwise software can be converted to run in double precision when you're zoomed in on a really, really, really fine mesh. So that's the second point, is the length scales involved. All our meshes are linear that we're generating now for CFD. They're not higher order elements. However, there is a movement in CFD to use more high order CFD methods. In fact, there's a second symposium on that topic. It's going to be in Germany this summer. So I think that from a CFD standpoint, we'll be driven to go down that route for higher order stuff. You can actually take a linear mesh out of Pointwise right now and write it out in a number of neutral formats, like Nastran is an example of a de facto kind of standard. And we have customers who have taken them out and done structural mechanics calculations with them. So there's nothing to prevent you from doing it now. It's just not the market where we have a whole lot of expertise, personally speaking. And I think that in the future, the technology standpoint, we may go to the higher order elements and things like that. From a business standpoint, why or why not, or wouldn't we do that? When you look at the FEA market, it's much more mature, I think, than the CFD market is, with established, well-honed tools. It's not necessarily a competitive environment that I would relish jumping into the middle of, especially pre-processing boundary conditions, loads, those kind of things, which is completely foreign to us. Developing all that and delivering that technology in a competitive environment would be kind of tough. I'd be happy if people could take just the meshes, use Pointwise as a mesher, and then pull the mesh into their favorite FEA pre-processing tool and generate the mesh and go forward with it from there. So there's business reasons that we ended up where we are, and there's technology reasons as well. None of them are insurmountable. And hopefully there's going to be some crossover, especially as we get people who are driven more toward doing fluid structure interaction and things like that.
Yeah, it seems like, if you can go to that level of detail and, create such an exquisitely complex mesh for CFD, then you ought to be able to handle the sort of ho-hum easy stuff in FEA. Now we're going to get some FEA guys who hate us now, but hate me because you did not say that. But I think you make a good point. One thing I've learned in software is you can't be all things to all people. It's probably true in life, and focus is really, really important. So you've got that expertise level. If somebody comes to you with the kinds of problems that they would need your software for, they're going to want somebody in their corner like you, I suppose.
Well, we also do kind of interesting side projects that might take us in certain directions they're not necessarily our standard type of application or customer. I mentioned a little bit a while ago that one of the things we've done with our new architecture in the Pointwise product is to make it highly customizable. And one way we've done that is we have a fully integrated scripting language that covers all the code's functionality called glyph, which is based on Tickle. So this is where all the Python fanatics hate me. And what they're able to do is we actually wrote a script, one of our engineers, that would take one of our linear meshes and elevate its polynomial degree and then write it out for, say, nastran or something like that. So we can actually take our core meshing technology and use the scripting capability to customize it and then write out something that could be truly used for FEA. So that's an example of how the code being extensible allows us to maybe serve non-traditional customers as well. But I agree with what you said. It's absolutely true that if you try to please everyone, you're guaranteed to please no one. So from a software standpoint, CFD is kind of where we're at right now, and we're kind of happy to stay there.
Well, so the industry's changing. We've got this push towards open source. I think one of the other more notable changes happening in the industry right now is something that I think you coined this term, and you're a big fan of the democratization of CAE. Is that true?
That's absolutely not true. I'm glad you tried to lay that one at my feet. As I think you know that it's not a word that I like. I know it's just a word. I know it's a euphemism that people intend to mean let's make CAE software more accessible to non-expert analyst engineers. I just don't like the term at all for a number of reasons. Number one, when I think of democracy, when I think of democratization, I think of democracy, I think of Washington, D.C., I think of Congress. And when I think of Congress's daily struggle to achieve mediocrity, it just depresses the hell out of me. So that's one reason why I don't like it. The other is I get this weird image as though all these non-analyst expert engineers are standing in some kind of Soviet-era bread line waiting for us enlightened people to hand out CAE software to them so they can go about their business like we're granting them some great privilege. I just don't. So from a euphemism standpoint, it's just not working for me. But from a practical standpoint, I don't think it's anything new. Hasn't the push or been a large percentage of the push in software development in the CAE business over the last 20 years been about ease of use and opening access to other people? What's the sense of labeling it? What's going to be different? Do you know?
Yeah, so I spent a lot of time trying to push CFD in particular into the hands of, let's say non-experts, and, believed in it wholeheartedly. And I still do, although I was at a conference last week at SemData. I have to remember the gentleman to attribute this to. I think his name was Mark Baum, but he said, hey, let's just not call it democratization. Let's call it proliferation. And that sort of crystallized with me. I definitely agree that the use of CAE in general needs to, spread in, the more that you can do in the virtual space before you get out to the real world for physical testing, the better. Everybody believes that. Everybody will admit that. But, I think some people think that democratization means that you are, taking a tool like, let's just say Fluent, for example, and putting it in the hands of a design engineer. And, all hell will break loose. Children will be murdered. Your company will go into bankruptcy, all the bad things. But I don't think that's necessarily what proliferation means. Proliferation could mean just that we're doing a lot more analysis before we go cut metal.
Well, sure. I mean, again, I think that is a very laudable goal, and I think that's a goal that a lot of people are and or should be heading toward. It's not for everyone. I don't think we should say that. And there's a lot of fear there because we talk about democratization or proliferation in a very generic sense. Each of us has kind of our own vision of what that means and who we're going to be doing that for. There's a current thread on some CFD-related LinkedIn group that I'm in where someone proposed purposely a kind of a controversial question and said, would it be dangerous to put CAE software in the hands of designers? I'm paraphrasing, but that word danger was used. And I'm like, again, depending on what you mean by that, is it dangerous? I think I posted something like to the effect of, we let everyone with a pulse who's over the age of 16 drive a 2,000-pound missile at 70 miles an hour. That's dangerous. So I think we might be overthinking whether or not an engineer should be able to run fluent.
That was Kenneth Wong, by the way, from Desktop Engineering, that I think purposely tried to stir up a debate. Yeah, I'm glad he did.
Right. And, there's responsibility to be had all around. This isn't, democratization shouldn't be taken as a finger pointing at the CAE vendors saying, why isn't your software easier to use? There is another component there where the intended end user also has to have his requisite set of skills in terms of understanding at least the garbage in, garbage out mantra, so that they're aware of and can validate based on their own engineering expertise whether the answers they're getting are good or not. It's certainly within the idea of democratization or getting software out into the hands of more engineers. The part that I'm most closely associated with, meshing, is something that we really need to shrink or encapsulate to make that go away. Because certainly, someone who's not an expert analyst really needs to know as little about the mesh as possible.
Agreed. So there has to be some sort of expert guidance behind the scenes, an applet or something like that, if you're going to have any luck with that, and tied to the exact application that you're trying to solve.
Exactly. That's a nice segue and straight line for me to go into the fact that, again, one of the reasons why with our new architecture and our new scripting capabilities, it allows templates to be written that an end user organization can customize our software to mesh anything they want with any parameters they want. And there are examples of that on our website and things like that, to kind of so that the expert analyst at an organization could say, okay, I'm going to make a template that meshes, widgets, so that I can give that to my non-expert analyst engineers who can actually use it to mesh and then run the CFD jobs and get the answers.
And in that scenario, this widget, if you will be built for the refrigerator that you make, or something very close to the refrigerator you make. But if you try to put a basketball into that widget, it's probably not going to work.
Exactly. Yeah. And that was one of the realizations, basic premises of looking at our new architecture years ago when we started out. It was going back to the things of, we can't really be everything to everybody. We can't really automate everything. So let's give the end user the ability to really kind of drive the software in places that we can't anticipate.
I think that's really smart. I think that this is my personal prediction in the future, but I think we're going to see a lot more of that. That's what, if you want to call it democratization or proliferation, I think that's where you're going to see it most successful.
Yeah. So for me, I know you kind of baited me with that question. I just don't like the word. I'm not really sure why it needs to be popular now, because again, I think it's been an ongoing theme for all CAE software providers. We're always looking at ease of use, streamlining, automation, things like that, things that would allow democratization. There's large efforts in terms of robustness of solvers, accuracy of solvers. How can we do validation and verification to make sure that this stuff is giving the right answer most of the time, especially within a bounded space for industry A, industry B, and industry C, things like that.
All right. Before we wrap up here, I just need to shift the topic a little bit. You clearly have this engineering background, and maybe not everyone knows this, although if they look closely enough, they could see it. This seems to be a pretty good part of your background or interest in the arts. So I see that you have a heavy interest in, I think, modern art, which is baffling to me personally, but I appreciate that you can appreciate it. And then reading and writing. So you're a prolific blogger. I don't know if we can certainly talk about your corporate blog if you want to mention the secret blog. That's one of my personal favorites every week too. But how did you get started in all of that?
When it comes to blogging or writing, the key there for me is I've always been a big reader. So I read all the time. Being a prolific reader is a relative term. I read maybe 30 to 40 books a year, a mix of fiction and nonfiction, work-related things. The transition to writing kind of comes naturally for a number of reasons. Number one, for business books, writing allows me to take notes and, digest better the things I've just read, especially things that are applicable and implementable in our business or in our products. So I start taking those notes for my own reasons, and then you start saying, well, why the heck don't I share that information? From the standpoint of technical details, I'd always like to share in-house with other people here interesting news items I pick up off the internet or reading, from various media saying, oh, you ought to look at this article about so-and-so just came out with a new software product, or so-and-so gave an interesting talk at this conference, and I'd share that information, and pretty soon it became a natural to then write about that for a wider audience. The company blog, Another Fine Mesh, which you can find on our website, pointwise.com, is kind of a extension of that. It became just a very natural thing to say, let's use this as a vehicle to share information about what's going on at the company. And to be honest, I write a weekly feature for that called This Week in CFD, which started out, it was a fear-based thing because, I have a great deal of respect for people who can write good quality content on the internet or anywhere on a regular basis. And in a quest for content, it was like, well, how about if I just do this week in CFD and compile all this information I've already found anyway and post that up there? And it was like, my God, I got to have something to write, so I'll use this. And it turned out to be pretty popular, and there seems to be a lot of readership in that. So I like sharing that kind of information with people. I'm a big fan of social media, as you know. Twitter is my favorite. I think it's a great way to share ideas about, again, the same kind of thing. Here's an interesting article. Have you seen this new product that someone came out with? It's in 140 characters. That brevity being the soul of wit definitely holds true here for sharing that information and getting it out in a very compact form. So that's kind of where the writing idea comes from. And I think that's one thing I always stress when I go to universities to talk to engineering students is they really need to learn how to write well, write prolifically, because they're going to be doing a lot of it, more of it in their career than they ever thought they would.
Yeah, I'm pretty sure I've read some comments from you in social media or maybe on the blog, but talking about really bad examples of candidates coming to you, looking for jobs that, basically didn't pass muster because of either writing or presenting or speaking skills.
Well, the classic example is a resume that I keep a copy of in my desk. I keep a redacted version of it, so it's completely anonymous, but it had, on a single page resume, it had 35 spelling or grammar errors, all of which I've highlighted in yellow. And I keep that around as an example to talk to students and say, look, just if you're going to send in your resume for a position here, show at least a little effort that you've gone and done some proofreading and things like that. Just do the minimal effort that's required to express yourself in writing. And I think that's a big part of the undergraduate experience is learning how to write, even for engineers. I mean, you will write lab reports in your career. You'll write progress reports, justifications for funding, final reports, all sort of reports, even little inter-office communication. It ends up being, how you're judged by your peers. You don't want to be the guy in the company who's known for being a poor speller, especially since a lot of the email tools have built-in spell checkers. But I read an interesting article the other day that extends this idea to non-engineers. So it's not a problem that we need to lay at the lap of young engineering students. An English professor was talking about how incoming students of all varieties in her classes really don't know how to read, don't really know how to read all the words on a page because they've gotten through secondary school with just being able to react to writing by expressing their feelings about it instead of the actual written words, the precise written words, and the precise meaning involved.
Yeah, for me, it's yes, if I see a misspelled word in certainly in a professional email or God forbid, something that's already been committed to copy on a brochure. I think, it's that people don't know how to use this brevity that you mentioned before. I think my bigger concern is, I'll get something that's very short and has no information, or is, War and Peace long. And, it's got way too many artifacts. It's too hard to follow. Maybe I'm attributing this to Mark Twain, who said I would have written you a shorter letter if I had more time,
That's exactly the quote I was just thinking of in response to what you were saying.
Yeah. And that, I just don't see it in, you're right. Not just in engineering. Most people seem to not be able to do that. And, as an aside, last week I read this great book by Stephen King called On Writing. And it's on writing. And he starts off with a little bit of, sort of autobiographical info on himself. And he starts, the last half of the book is more about, if you want to be a writer, here's the things to pay attention to. Have you read that book or ever seen that?
No, I haven't.
Yeah.
I'm not a huge fan of Stephen King anyway, so I wouldn't necessarily seek him out.
Okay. So, one thing that he says in this book is that you can take a terrible writer and make him a good writer. But you can't take a good writer and make him a great writer. And, I think his point was that some people just have it and some people don't. And that, at some point you shouldn't try to force it. But I think there's, for me, I still think there's a median level of proficiency that anybody, certainly in engineering, ought to aspire to.
Well, sure. And doing, practicing writing via social media, like having your own blog or writing articles for your website or a newsletter or simply using Twitter or Facebook or whatever, is a great way to develop that, because it simply forces you to practice and to gain feedback over time about how long it takes to write something, how to get salient points across, and things like that. Now, granted, writing for the internet is a very different thing than writing for the non-internet audience. They're very different things, but still, that practice is how you develop those skills. Well,
John, I really appreciate you coming on today. We actually ran over. I was enjoying the conversation. Where can people find out more about you, more about Pointwise, get in contact with you if they do have specialized CFD meshing needs?
The main thing would be to look for our website at www.pointwise.com. That has links to everything we talked about, including the blog and other fine mesh.
Fantastic. That's all for this episode. Thanks for listening to the Life Upfront Engineering Podcast. Visit lifeupfront.com to comment and connect with me on Twitter, Google+, and LinkedIn. Also, you can really help the show by leaving a review on iTunes. Thanks again. Until next time.